Okay, this is the special video to go along with the review packet for the third quarter cumulative test. This packet is not required for a grade, but I'm giving you this video of answers so that you have an idea whether you are prepared for the cumulative test on the weekend or not. All right, number one. And you'll notice that these do bear a vague resemblance to questions of previous review sheets, but I did go back and change the numbers on them so that they're not exactly the same thing. For instance, I think this one used to say not green, and this one I said not red. Well, when you add them up, they still add up to 10. And not red, there are 2 of them that are red, which means that there would have to be 8 of them that are not red. 3 plus 1 plus 4 does make 8, which of course reduces down to 4/5. Now, when you're rolling one die, you have 6 possible outcomes. No less than 4. That would be 4 or 5 or 6. There are 3 out of the 6 possible outcomes. Now, when 2 dice are rolled together, that's where you need that little chart off to the side, sum and ways. And the sums go from 2 through 12. And the ways start from 1 and go through 6, and then go back down again. Now, probability that the sum of 6 is rolled. So basically, you're looking for this guy right here. And so he is saying that there are 5 ways to roll a 6. You can have a 1 and a 5, a 2 and a 3, a 2 and a 4, a 3 and a 3, a 4 and a 2, and a 5 and a 1. So that would be 5 out of the 36 possible outcomes of rolling 2 dice. All right, a 9 or a 10. There are 4 9s in the deck. A 9 of clubs, hearts, diamonds, and spades. And there are 4 10s in the deck. And the fact that this is an or says that you will add those. There is an 8 out of 52 chance that you will draw one of those 2 cards out of your standard deck, which that can be reduced down to 2 over 13. Probability that it won't rain, if there's a 23% chance of rain today, you're talking about a 77% chance that it won't rain. Because these guys have to add up to 100% for all possible outcomes. Either it will rain or it won't. Cow pie bingo. All right, we've marked off the field into 1,000 equal squares. This time we're selling the tickets for $10 each, and the winning square gets $5 grand. And Egbert only buys 1 ticket. Apparently he hasn't got his STEMI check yet. All right. Yes, Mrs. G is chuckling over that. Let's see now. He either wins or he loses. And he has a 1 out of 1,000 chance of winning. And there is a 999 out of 1,000 chance of losing. Now, if he buys the $10 ticket and then wins the 5,000, that's $49.90 that he'll walk away with. And if he loses his 10 bucks. So, let's see now, that divided by 1,000 is going to make $4.99. And if I multiply this by 10, that actually takes out a decimal, and we're going to wind up with something like that. Yeah. And so by the time I put these together, it is negative $5 for his expected value. Okay. All righty. Dilbert cleans gutters for a living. He's making a bid to the local golf club house. The bid is going to cost $100, but he could make $10,000 a year if he wins the bid. There are two other bids besides his, which means that there are a total of three, and they have an equal chance of winning. So he either wins or he loses. He has a 1 out of 3 chance of winning. He has a 2 out of 3 chance of losing. If he wins, he makes the $10,000 less the 100, which would be $9,900, or he just simply loses the 100 that he spent. All right, so 1/3 of 9,900 is 3,300. That was quick and easy. And 2/3 of a negative 100 is going to wind up being negative 66.67. So by the time I put these together, his expected value is going to be 33.33. Okay, and that is his expected value. All right, here we are in the realty business again, Filbertina this time. And she is listing a house for $300. Now we know the deal about 3% commission on listing and 3% on actually selling it. So 300,000 times 3% is $9,000. So she gets $9,000 just for listing it, and then she'll get another $9,000 if she sells it. Now she did spend $1,500 in advertising. So let's see now. There's the idea that she could sell it, or another could sell it, or it doesn't sell at all. All right, and remember, she only gets the $9,000 for listing it if the thing sells. So here she's listed it and she sold it. That's $18,000 less the $1,500 in advertising. That would be, oh wait a minute, now we forgot the probabilities. She estimates a 50% chance she'll do it, 40% the other will do it, and 10% that it won't get sold. She likes this property and she thinks it'll move. Now, 18,000 less 1,500 is 16,500. Half of that is going to be 8,250. Now, if somebody else sells it, she still gets the 9,000 for listing it, less the 1,500 for advertising. So that's going to be 7,500. That's going to be $3,000. And then if she doesn't sell it, she'll lose her $1,500 in advertising, which a tenth of that is $150. So that's 11,250 minus 150 is 11,100. Expected value. That's pretty good. And part of that is that by her estimation, this should sell. You know, there's got a 90% chance of somebody selling it. All right. Lugbert gets a strike on 40% of the frames when he bowls. Each game has 10 frames. So what's the probability of Lugbert getting a strike on no more than 3 frames? Well, this gets into that NCR business of there are 10 frames, and he wants no more than 3. No more than 3 is going to be 1, 2, or 3. Well, 0, 1, 2, or 3. So we're going to start with 0, and we're going to do 10-1, 10-2, 10-3. Now, he gets a strike 40% of the time, which means 60% he doesn't. Speaking as somebody who used to bowl in a league once upon a time, 40% is pretty good. It's not an easy thing to get a strike on a consistent basis. All right, so that 0 goes here, that 1 goes here, and so on and so forth. 10 minus 0 goes here, 10 minus 1 goes here, and so on and so forth. And so next we go to Desmos and figure out what each of these 4 numbers are. Now, if I go here, I haven't gotten Desmos yet, have I? Then we do that. And I go to functions, and I go to stats, and there's NCR down toward the bottom. And I'm going to put in 10 and 0, and then 0.4 and 0.6, and then I'll go back and do the exponents to the 0 to the 10. And that tells me, and we'll do 4 decimal places. 0, 6, 0. And then when I change out for 1 and 1, whoops. And 9, I get 0403. And then I change out for 2, and 2, 8, I get 1209. And then I come back and I do 3, and 3, and 7. I get 21499, I'm going to say 2150. That 499 is going to force my 4 to go up to a 5, and I'll have a 0 to go with it. Now, I need to add these. That makes 12, carry the 1. That makes 12, carry the 1. 4 and 6, 7 and 8. And then I've got a 1 and a 2. So he has about a 38% chance of getting a strike on 3 or less frames. Okay. Now we have a game with dice, and we're asked to calculate the expected value and the fair price. Same problem. So let's see now, you're rolling 3 dice, which means we're not going to be doing a ton of these. If you're rolling 3 dice, you're either going to get none that show up as each time a 1 appears. So I'm either going to get no 1s, I'm going to get 1 1, I'm going to get 2 1s, or I'm going to get 3 1s. Now, if I'm rolling a die singular, and I'm looking for the probability of getting a 1, that would be 1/6, which means I'm going to have 5/6 chance of not getting a 1. And so I'm going to copy those onto the rest. And then we'll do our exponents. 0 goes there, 1 goes here, and there's the pattern. 3 minus 0 is 3. 3 minus 1 is 2. There's your pattern. And then we go to Desmos to figure out the 4 numbers. And then we're going to have to figure out the winnings less cost. That is around the corner. All right, so here we are doing 3 and 0. And we're doing 1/6 raised to the 0. 5/6 raised to the 3rd. All right, so that gives us point, and I'd like to do 3 decimals when I'm, calculating with money just because it makes it a little easier. I'm going to say 579. And then we go back in and we say, all right, what about 3 and 1? And it's going to give me 0.347. 2, 2, and a 1, 0.069. And then a 3, and a 3, and a 0. And I get a 0.005. That 6 is going to push the 4 up to a 5. All right. So those are my percentages in each case. Now I need to look at the winnings less cost. So I'm going to win $5 each time a 1 appears, and I'll lose $1 if none of them show a 1. Now there is, or it does cost $1 to join. So it costs $1, then you lose $1 on top of that. So you have lost $2 if nothing shows. Now if you get 1, you'll, oh, excuse me, wait a minute. You'll win $5 for each time a 1 appears. So 5 less the 1 it cost is going to be 4. This might be a game worth getting into. If you get 2 1s, you'll get $10 less the $1 that it costs to join. And if you get 3, you'll get $15 less the $1 it costs you to join. So now we need to figure out what each of these create and then add down. I'm going to pause and do the calculation and then come back. All right, so that's what the calculations are going to look like. And by the time you add them, you've got 16, 18 less 6. Oh, that's probably not a good way to do it. All right, that's going to be 69 added with him is going to be 328. Which is going to be 212. So your expected value here is 212. Now, we had said at one point that the fair price was equal to the cost plus the expected value. The cost was $1. The expected value is 212. So if you really wanted to break even, you should be charging 312 as a fair price to get in. Then everybody's breaking even. All right, I think I'm going to pause there and do a second video for the other half. Because I think we're about halfway, if I'm not terribly mistaken.